This assessment asks us to tell which is more stable of a diene based on the different heats of hydrogenations. So this 1,3 diene up here, we've labeled A, our conjugated alkene, has a delta H of negative 53.7. So 53.7 kilocalories per mole are released upon hydrogenating it. Our 1,4 diene, the so-called non-conjugated, releases negative 60.2. So when we're given these delta H's, one way to do this is just to remember that a certain relative delta H means one is more or less stable. I really like to use reaction coordinate diagrams to help with this. And here's why we can in this situation. Because the product in both of these reactions is hexane. And so if we're looking at the energy of these, both A and B will finish at the same spot. So we can draw our orange and our blue line in the same position. Now, if B releases 60 kilocalories per mole, or 60.2 kilocalories per mole, we can start that reaction here and have it finish down there where this value here corresponds to that negative 60.2. Now it's going to get a little bit messy because I'm going to write over that. But what does that mean? What does that tell us? If negative 60, if something that releases negative 60 starts here and finishes here, and we know that A finishes here, where must it start relative to where B started? The fact that it releases less energy means it must start lower. Finishes at the same spot. This value, so I'll dash the line, this value here is the negative 53.7. What does that tell us? That tells us that the conjugated diene is more stable. It starts at a lower energy because it is a more stable molecule.